Hello. We are going to do some analysis on strategic interaction, some very basic examples that you might see in intermediate microeconomics or something comparable to that level. So the situation that we're looking at here, we have two firms, firm A and firm B. Inverse demand is given by this expression here, P equals 15 minus Q. You can see that the price is decreasing in the amount of quantity that is produced, and the market quantity is the sum of the quantities produced by firm A and firm B. In this example, they have equal marginal costs, and the marginal cost is 3. Okay, so let's set up a baseline situation here where both firms get together and they decide to collude and form a cartel, and they want to choose the quantity to maximize joint profits. Okay, so let's see what the equilibrium quantity and equilibrium price under that situation, and then also the equilibrium profits. Okay, so we're going to maximize the cartel's profits, so the subscript C, that stands for a cartel. Okay. We got the price times the quantity minus the marginal cost times the quantity. And so this is going to be total revenue, be total cost, and we want to choose Q to maximize this. How are we going to do that? Well, let's take the partial derivative with respect to Q and set that equal to 0. Okay, and so if you take this equation here and solve for Q, it looks like you're going to get Q equals 6. So the market output, equilibrium market output, is going to be 6. And I know because both firms have an equal marginal cost, they're both going to produce the same amount of output, so we can deduct from this that the output for firm A is going to equal 3, and that's going to be firm B's output as well. Okay, and so then we can take this 6, the total quantity, output quantity, and substitute that back into our expression for price, and it looks like your equilibrium price is going to be 9. Okay, and then let's calculate profits here. So the profits for the cartel are going to be the price, so 9, times the output, which is 6, minus the marginal cost of 3, times the output of 6. So it's going to be 54 minus 18. It looks like we have 36. And then we're going to split that evenly between the two firms. So it looks like each firm in equilibrium is going to earn $18 of profit. Okay. So that's if they get together and decide to be nice and cooperate and operate as a cartel in such a way where they're going to maximize their joint profits. Okay, so that doesn't typically happen in the real world, and it's actually illegal in the United States, but we do like to do it just for illustrative purposes. So let's now assume that they are not, firm A and firm B are not working together. They are not going to be in a cartel, and now they are choosing price. So they're competing on price. And so when firms compete on price, at least in these examples, when we're in economics, they're choosing price. And so the way that you approach this problem is you look at the marginal cost of each firm. And in this example, they're equal and they're both 3. We can also look at the inverse demand, and I can tell that there's somebody out there willing to pay $15 for whatever we're selling here. And so I'm trying to, if I'm firm A, I'm trying to decide, well, what price should I charge to maximize my profits? And firm B is thinking the same thing. Well, firm A and firm B are both aware that each other's marginal cost is 3. And they're also both aware of the market demand. And so if firm A and firm B are thinking about how best to choose a price to maximize their profit, it's the logic kind of unfolds something similar to this. So if I'm firm A, I'm thinking, well, if firm B chooses $14, I'll just choose $13.99 and take the whole market. Well, firm B knows that I'm thinking that, and they'll say, well, I'll just go ahead and undercut firm A and charge $13.98. Well, then I'm sitting back, and then if I'm firm A, and I'll say, well, let's go down to $13.97. And so you keep thinking like that, and then the price that is settled on, or the equilibrium price in this example, because the marginal costs are equal, is going to be 3. So if both firms choose 3 as their price, then I'm going to substitute 3 in for P. Okay, and this is going to be your total output for the whole market, and it looks like that's going to be 12 here. Okay, and so because the marginal costs are both equal for both firms, we're going to, when we know that this is going to be 6 for each firm. Okay, so the equilibrium output is 6 in that situation. What about profits here? Let's go ahead and calculate those. So we'll just do one firm here, firm A. So the price, let's find the price real quick. So if we plug 12 into Q up here, quantity, we can see that the price is going to be 3, and we already found that. So just write that down here. Equilibrium price, equilibrium quantities. Okay, so what are the equilibrium profits? Okay, so price of 3 times firm A is going to produce 6 minus their marginal cost of 3 and times 6. So this is obviously 0, and that's exactly what we would expect to happen when both firms are choosing or competing on price, because they're going to compete that price all the way down to marginal cost, and both firms are going to walk away with 0 profit, and both firms are going to split the output evenly. And so in this situation, it's going to be each firm is going to produce 6. And we know that'll be true for firm B too. So both firms earn 0 profits. Okay, well, what about third situation? Firms are going to choose quantity to compete against each other. So in this example, firm A is going to be choosing QA, and firm B is going to be choosing QB. So if I'm firm A, I'm thinking, well, I want to choose my output given my expectation of what firm B is doing, so as to maximize my profit. So we're going to evaluate this problem or analyze this problem from both sets of shoes, from firm A's shoes and from firm B's shoes. So let's go ahead and start here from firm A's perspective. So firm A wants to maximize profits. So we've got the price, and I'm going to substitute in QA plus QB for capital Q in this expression. So I'm going to take QA plus QB and put it in here for the price. So minus QA minus QB times the amount of output QA is producing minus their marginal cost times their output. Okay, so you're going to see, let's go back up to the price. You can see that the price goes down as more output is put onto the market. So obviously firms are going to want or prefer a higher price, holding everything else equal. And so that's kind of the balancing act that we're trying to, that we're dealing with here. Because I know that the more firm B, if I'm firm A, the more output firm B puts out, the lower my price is going to be. And firm B knows that if I'm firm A and I put out more output, we're going to have a lower price. Well, firm B is going to have a lower price for the units that they sell. Okay, so from firm A's perspective, I'm going to partially differentiate this with respect to firm A's output. And the partial differentiation implies that all the other variables are being held constant. And so just an added piece of intuition here, I'm assuming that QB is being held constant at its optimal value. So I'm assuming that firm B is going to choose the optimal level of output given what they know about the market, given that they know about this market demand, given that they know about the marginal cost. Okay. 15 minus 2QA minus QB minus 3 equals 0. Okay. Go ahead and solve for QA here in terms of QB. Looks like we've got minus QB over 2. Okay, and so what this is this is firm A's output, their optimal output, as a function of firm B's output. So this is firm A's best response in terms of choosing their output given what firm B is doing. And so we call this a reaction function. Okay, and so this is told this here. This is reaction function for firm A. Now I'm gonna hold this right here. Now I'm gonna go ahead and do this from B's perspective. So I'm gonna pretend I am firm B now. Okay, so 15 minus 2QB minus QA. You notice this is the exact same equation except we're switching QA and QB around. We know this because of the symmetry, in their marginal costs, or 3. So I automatically will know that QB equals 6 minus QA over 2. Okay, so this is the reaction function for firm B, for firm B. Okay, so we have two equations here now, two reaction functions. I will put these in a graph, and then we'll go ahead and use simple substitution to solve for the equilibrium values here. Okay, so output of firm 2, output of firm 1. So I'm looking at my reaction functions here. So I know this is going to be A, this is B, not 1 and 2. I know that if QB is equal to 0, then this is going to be 6. And if QA equals 0, that's going to be 12. So this is firm A's reaction function. Okay, and B's is going to look almost, well, it's going to be identical, except expressed in terms of QA. And so firm B's reaction function okay, so these are going to be, this is a graphical depiction of what our solution is going to be when we actually solve it. Okay, so I'm going to write my reaction functions back out and use simple substitution to solve for the equilibrium values. So firm A's reaction function is, and firm B's is 2. Okay, so I'll call this 1, I will call that 2. I'll substitute 2, I'm going to take QB and put it in here and put that into equation 1. Okay, so QA, again, I'm just putting QB in here. 6 minus this whole thing divided by 2. Okay. Simplify this. Okay, and so I know that the equilibrium output for firm A is equal to 4. Firm B is going to be equal to 4 as well. I know that because the marginal costs are identical. So if you would have taken QA and put it into the second equation for QA, and solve for B, you would get QB equals 4. These are the equilibrium outputs. Okay, and so what about the price? So we know that the total output is going to be 8, so we'll go back to our expression for price, which is 15 minus Q. We'll plug 8 into that, and we'll see that the equilibrium price is 7. Okay, and so what are the profits going to be? The profits are going to be the same for each firm. Let's solve for A real quick here, and we see that the price is 7 times the number of output for firm A is going to be 4. Okay, 28. Minus our marginal cost of 3 times 4 of output, and so 28 minus 12 is going to be 16. So each firm earns $16 of profits. Okay, so the profits are the highest for both firms if they collude and form a cartel. They go to 0 if they compete on price, but if they compete on quantity, it looks like we have positive profits and they're 16. So that's it for today, and thank you very much.